Hello and welcome to Chapter 8, Network Troubleshooting. This is an important chapter because we're going to be able to talk about the different types of troubleshooting methodologies, and we'll take a look at some scenarios. Most likely your first day on the job will be maybe a help desk or some sort of trying to figure out what the actual problems might be on a network and trying to resolve it. You'll be an assistant to somebody as a network engineer. Troubleshooting and figuring out what the problems are will help you not only have your network being expanded without any problems, you'll be able to monitor the network and you'll be able to do something on your first day on the job. Gathering information and figuring out before any problems occur is probably the best thing to do. And if you are hired to be a network engineer that's going to design a network from scratch, of course, you want to design it in such a way so that you're not going to have any traffic problems. User problems will always be there, but the traffic problems, the design should be, and security, and make sure it's scalable, easy to expand. All of that has to come into play. And just as a reminder, when you are designing a LAN, you want to use the three-layered model where you have a core distribution and the access layers. Those are the three layers and it's a hierarchical, like a tree. Everything goes to the top and flows much smoother because the hierarchical method allows you the network is scalable, more secured, easier to manage, and easier to troubleshoot when you got problems. All right, anyway, so let's take a look at the different types of troubleshooting methodologies that are out there. Documentation is extremely important. As I've just said a minute ago, first thing that you want to do when you're on your first day on the job is you don't even need anyone to help you out, to hold your hand and show you around the organization. What you could do is document the whole logical and physical topology of the network. Figure out how the whole network is connected. If they already have this laid out, go ahead, pick that up and trying to pinpoint where all the devices are, what their IP address is, who they are, what switches they are connected to, what applications, if you can get into the security. In other words, you know, what each LAN has access to and what they don't have access to. Learn everything about the network and how they are connected and who's connected to what. Is there any remote access? You can spend weeks doing that without anybody's help, and you have the tools, you know, to be able to do that on your first day job. From what you have learned in school, you can actually create a great documentations of the physical and the logical topology. So that will ease, those butterflies that you get on your first day on the job. You don't know what to do. But if you can get in there and you have a plan of what you can be doing, that could make it a little bit easier. And of course, down the road in 3 or 4 months, once you all of that, by the way, you are going to need how the whole, if you are responsible for the network, you're going to need how they are connected anyway, regardless. You don't want to spend, you want to do it on, you know, only on a need to need basis. So you want to take care of that up front, learn everything. And once you know that, not only you can your troubleshooting becomes a lot easier, but you know how to expand. You can actually give suggestions on how the network should be more secured. For example, if you noticed any problems with that, if the design is all screwed up, you probably can and fix it a little bit, enhance it. It all depends, right? So documentation is extremely important. So here's your first thing that I want you to write down. What other documentation should include? Write down the configuration files, the physical and logical topology, and a baseline performance. That's also important if you could do that. Figure out where all the traffic, where the bottlenecking is. What does a normal traffic occurs? You can use SNMP, you can use a software that we've discussed earlier we're using the span ports with the port mirroring to allow you to gather information and build a baseline performance, maybe done weekly, monthly. You know what's normal traffic, whatever normal is. And then you can probably, by looking at that, you can actually figure out if you can help in enhancing the network in terms of traffic security and make it more scalable if possible. All right, so to be able to get the baseline, you want to be able to determine what type of data that needs to be collected, the devices and ports of interest, and determine the baseline duration. How long is it going to be? A week, a month, and so on. But if you purchase a software to do that, it makes it a lot easier that way. If you don't have that and you want to do it manually, if you have a small enough network, you can use any of these commands to document that information. Use as much as you can. Show version tells you, for example, what version of the operating systems that you have on your routers and switches. Show interfaces will give you detailed information about the interface in terms of the IP address, the encapsulation if it's PPP or HDLC, whatever, right? Show IP route. Actually, when you type show IP route, you'll be able to build a routing topology. Yeah, routing topology. You can actually build a physical topology by just looking at the routing table. All right, so you can actually think about looking at each of those utilities and they'll tell you exactly what information do you get. That's probably a good idea to try some of these commands and look at the output and see what they can tell you, and you can document all of that. All right, the troubleshooting process. I want you to write this down. That's important because troubleshooting is really, nobody can tell you, nobody can teach you to be a great troubleshooter. That doesn't come. Um, what you need is education. You need to know how the device or the network works. That's why you need to learn everything, how everything operates, how everything flows, where everybody's connected to, who they connected to, what they have and don't have access to. All right. And then you can notice if there's a problem, right? And so it takes a little bit of a while. And then experience. So education and experience is how you become a great troubleshooter. Experience means once you learn how to fix something, you document it, right? That's step number 4. Because if you don't because then you have a logbook of everything that happens you can always go back to, right? Don't think that you're going to remember everything. And not only when you document, you want to be able to, no, just don't say that, you know, so and this was happening and I fixed it. That's not good enough. So what you need to do, the more details you write about the problem, the sentence, the better. So the 4 steps are you gather information. So when you are gathering information, you ask questions. So if a user comes up to you and says, my hard drive is all acting up or my computer is acting up, what's the problem? So you probably want to ask them questions. When was it the last time it was working fine without any problems? Did you install or hardware or software? Can you replicate the problem for me? Does it happen at night? Whatever. So you gather as much information as you can, and from your knowledge about the system, how it works, you can probably have an idea of what the problem is. So I try to isolate the problem. Is it the NIC? Is it the software? Is it hardware? Is it connection problem? Okay, so you can actually use some commands. Now, you may have several scenarios of what the problem might be. Scenario 1, 2, 3, 4, 5. You go with the scenario that takes the least amount of time, even though the probability may be 10% that it may work. So for example, if I reboot the system, it's probably a glitch in the operating system, and something happened in the memory, and the operating system got confused, and that's why probably there's a failure. So if you reboot the system, everything works out fine. So you reboot the system. If it works, you're all good to go, right? That might take maybe 5 minutes or so. Then you write it down what the problem was, and rebooting it occurred, and rebooting it fixed the problem. So you implement that. Now, if you have to go to the scenario that 90% of the times it works by, reinstalling the software, for example, or removing something out of the network, or whatever it is, you still, you write down, and then you write down, by the way, in your documentation, you write down what you should not do, all the pitfalls next time. If this problem occurs, you know what not to do. That's important because a good engineer, a good troubleshooter is the one that is going to be able to save time in bringing up the devices or the network. So if you can notice a specific problems and you know how to solve it very, very quickly, you go right there and do it. You say, okay, I know I did this, and that did not work. So I should immediately, for example, if it's a virus, don't bother wasting any time. Just wipe out everything and reload an image, right? So that's probably saves you a lot of time. So that's what should be in the That's why documentation is extremely important. All right, so here are some troubleshooting commands that you could do. You can use the ping command, the trace route, the telnet. So ping command just tells you if the device on the network is connected. So when you ping something, you send out an echo request to the device, so it travels across the network, it goes to that device, and that device has to respond back to you. If the response back to you, that means layer 1 to 3, you were able to create a packet and send packets to each other. What's inside the packet, that has never been checked. So the ping just tells you that you are connected and you can pass data to each other. Now, if it fails, timed out, that means there's maybe a link or a device in the network that is on the way, does not respond or failed. So if you need, so what you need to do to find out exactly where the problem is, you can use trace route. Telnet, by the way, Telnet or SSH are two utilities that can test up to the 7 layer, because if you can telnet to a device, that means the application layer all the way to the physical layer is operational, right? If you can telnet to something, but you cannot access the email, then it's an application problem, right? Not connection, because the application layer through telnetting works. So that's why people telnet. If you can remote access anything, then it's really an application problem. It's a software problem. It might be security issue. An ACL, a firewall is blocking you from you doing email, but it's not blocking you from telnetting, for example. So telnetting is a utility that you can use starting with the upper layer. If you notice a lot of traffic, by the way, on the network, check if the debug command is on. Because if you typed debug something, debug will generate a lot of traffic trying to give you real-time information about what the network is doing, and it keeps running, and that will consume a lot of the bandwidth. Every time you do a debug, you have to turn it off by saying no debug all. In other words, undebug everything that you were debugging. Debugging is really when you type a show command, it gives you a snapshot of what's running right now. Debug is constantly doing a show command, like on and on and on and on. And you want to stop that, of course. All right, so those are the different types of commands that you could do to help you gather information. All right, so isolating the problem to a specific layer, you want to be able to say, is it the problem of connection at the physical layer? Is it a switch problem? The switch might have an issue. Or is it a router with the IP addresses, the network that you are in? Or is it an application problem? So the way to do it is you could either start from the application layer, from top to bottom, use telnet and try to isolate the problem. I don't know, if you think the application is the problem, and if you think it's a security issue, you can start from the top to bottom. If you think it's really connection problem, then you can start from the bottom up. Maybe the guy did not power the device, or the cable is not connected, or use the wrong cable. Any of that could happen. Uh, the best thing to do is to use divide and conquer. You start right in the middle, and most troubleshooting engineers, what they do is they ping. If you can ping a device, then if you cannot ping a device, let's say, then your problem is from layer 3 to the bottom. So you start working at the bottom 3 layers. If you can ping, then your connection to the bottom 3 layers are good. So you start worrying about, layer 4 and above. right? So this way you can it's much quicker that way, divide and conquer. So you use the ping or trace route, and then you can decide, should you go from the layer 3 up, or should you worry about the bottom 3 layers? Divide and conquer is probably the best way to go. So please write that down, isolating the issue using the layered model. So the 3 methods are bottom up, top down, or divide and conquer. All right, let's take a look at some scenarios. So you can actually use the Cisco SLA, the service level agreements, to actually gather information for you about the network performance in terms of traffic wise. It can tell you the latency, the delays, or the variation in the delay, which is called jitter, how many packet losses there are. So a lot of that stuff is really informative. If you could just do it by using the command, IP SLA, you can set it up using these commands. So please write that down, how to activate the SLA. So just write these commands down, these commands down that will activate the SLA ICMP echo configuration, which is ICMP, the Internet Control Messaging Protocol, using this, the ping command is an ICM protocol. And the echo request, echo is the ping, echo request is the ping reply. And the SLA is also an ICM command. So anyway, write these down, and this is the show command that you want to use for the SLA to give you the information that you need, or the SLA statistics. So those are the other 2 commands that I want you to write down to gather the information from the devices. If you do not have a software that does that automatically for you, you don't have, a GUI software. You can purchase that from a third party that you can install on your computer that does all of that automatically for you. All right. The troubleshooting tools that are out there. So I want you to write these down. There's hardware and software tools that you could use to help you troubleshoot. There's the network management tools that will do the device level monitoring, configurations, fault management, management tools. You have the knowledge based. You can use Google, for example. Google is a very helpful, when it comes down to when you're on the field, what's important, what tools do you have? And Google could be a very important resource. Cisco could be, if you're trying to troubleshoot Cisco devices, Cisco is also a very important resource, cisco.com. Having your certificate can help you when you call Cisco for help. They can guide you step by step on knowing that you have a CCNA. They can, I think, if I'm not mistaken, they allow you several free calls when it comes to the service, when it comes to servicing your devices. Baseline tools, so that will draw the actual diagram for you. And protocol analyzers, the sniffers that you can plug into a wall and capture all the different types of data that is out there. And you're doing all of that to try to help you find out where the traffic is. You can actually pinpoint which device is really acting up and which one is not. And if you have physical connection, that might be having an issue. If you have physical connections, you can use any of the hardware devices. You can use digital multimeters to test instruments to see if they have enough voltage, or if there is the electricity is down, if there's a blackout or anything like that, if a device is burned out or something like that. You can use multimeters, cable testers to see if the cable, you can, what you do is you send a signal in the cable, you tap it on the other end so the signal can loop back. If the signal does not loop back, then there's a problem in the connection in the cable. Cable analyzers, portable network analyzers, network analysis modules, which could be very expensive, trying to look at the whole network, and they can pinpoint where the problem might be. So please write those down. The hardware tools and the software tools, because if you are on the job, they might ask you, what kind of tools do you need to use? And by the way, they are very easy to use. So even though if you never use them, it's just a matter of looking at the pamphlet or even looking at a YouTube video, and they tell you exactly how to use these different devices. So if you are going to be hired as a troubleshooting, your first job is going to be troubleshooting and fixing network problems. So you probably want to take a look at and go over the different types of software tools that are out there, and the different types of hardware tools. Look up videos on them and see how they are being used, and then you can say, you are familiar with it. Not an expert, but familiar. The learning curve is very, very easy. They're all try to, all these different companies that creates these troubleshooting tools, they want to make it user friendly as much as possible. You just do a couple of clicks and they get you all that information. But you want to be familiar with it, of course. All right, so here are some scenarios. For example, if the problem is at the physical layer, so you may have performance, power, for example, loss of connectivity, network bottlenecking. For example, if the cable is constantly connected to the power and it's not provided, when it gets heated up, the problem, the cable may fail. And so your system might reboot, for example, every once in a while, or loses power. So suspect that the cable is really being bad, especially if that cable is constantly providing power. A lot of times, the cable faults, the power cable I'm talking about, it could be the cable connected to the NIC or to the switch, maybe bad. If you notice a lot of noise, interference, CPU overload, something is heating up, all of that could be at the physical layer. So at the physical layer, you check for the cables, make sure that you have the right cables, make sure everybody has power, you connecting to the correct um, port, make sure the lights are on, and so on. So if you see an amber color constantly on, it did not turn green on a switch, probably configuration problem you have. Then you can move up to if everything's good on the physical layer, you can move up to the data link layer. So if you have no connectivity at the upper layer, if the network operating below the baseline performance, so if you say, whoa, everything's extremely slow, for example, too many broadcasts, because for example, next when they do bad, when they go bad, they start sending frames, broadcasting frames like crazy. I remember about, oh my God, almost 20 years ago, at DeVry, when we first moved to North Brunswick, DeVry University in North Brunswick, there was one problem where all the switches were just flashing like crazy, and that means the switch was constantly broadcasting frames that were coming in from one NIC. So nobody had connection to the switch because everybody was receiving broadcast messages. It was a broadcast storm. And the first thing that you do if that ever happens to you, all I had to do is just disconnected everybody and start connecting one at a time. And the first thing, when we started connecting, and when we connected one NIC and then the problem occurred, the broadcast occurred, we knew that NIC was bad on that device because that's the one that was broadcasting all of these frames. So that's one way of doing it, one by one. Anyway, moving up at the network layer, your network layer, your pinging doesn't work, right? You put somebody in the wrong subnet, for example. You got to check that out. The routing table doesn't exist. Maybe your routing protocol is not running correctly. So you type I show IP route, and you need to know, are you running OSPF correctly or EIGRP? Is there static routes, default routes? All of that you got to take a look at and see why you cannot reach a specific network from one place to the other. At the transport layer, it could be the NAT. Why aren't you getting on the internet? Maybe the NAT translation is not configured correctly. Maybe you're not supposed to. It may be the firewall using the ACLs, you being blocked. right? So that's something that you should take a look at. If you were able to ping, all these three layers are good, then you probably want to take a look at the NAT or ACL, which is most likely the problem is. If that's okay, then it's probably a security issue that not allowing you, within Microsoft, for example, you don't have permissions to access a specific application. So that could be an application issue, right? All right. Troubleshooting connectivity from the bottom up. So this is probably something that you want to write down. Please write down those 8 steps on how the common bottom-up troubleshooting steps. All right, so that's important because I mean, you don't even. What I would like to do is I like to go into step. Let's say another. I do the ping command, and either I can go, and if the ping command doesn't work, then I know I'll have to stop maybe up to step number 4. I'll troubleshoot up to 4 because I know 5 to 7 works, right? But if pinging works, then I start with step 5. That's divide and conquer, right? But if you'd like, a lot of people will like to go, you know, from the bottom up regardless without you even using the ping command. So you can start with checking the physical connectivity, checking the duplex, and so on, all the way to the end. So please write down those 8 steps. Again, all of that information in this chapter will help you on your first day on the job, knowing all that, because a lot of the times they like to give those troubleshooting work for the novice, the new, fresh network engineer that coming into the network. So again, documentation and knowing and learning how the system work is extremely important. That's what's going to make you a good troubleshooting engineer. All right, so that ends the chapter. Keep up the good work, and from there, I'll see you in class.